Let's see other problem from LeetCode. It's a coin change problem, and this problem is very popular in Amazon. So let's see which company asked more. So we see, the Amazon has asked this question many times, and also popular in the Google, and there are many other companies. Let's try to understand this problem first. It's a coin change problem, and here we have been given different coins. It's a one coin, you can say $1 coin, $2, $5 coin. It's a different coin here, and then these coins we need to use multiple times to make this amount, and we have to find out the minimum number of coins we can use to make this value. So what can be the minimum way? If you see the one, if I use this one coin multiple times, if I use the one 11 times, then I can make it 11, but in that case I need 11 coin. Let's see with the other way. If I use 5 2 times, 5 5 10, and then one coin here, so 2 coin of 5 and 1 coin of 1. So in that way I just need 3 coins, and 3 is the answer, because we just need the minimum coins. So this problem says, okay, what is the minimum number of coin to use here to make this amount? So I think the problem is very clear. Now we have to think how to solve this. So I'm going to talk about 3 different strategies to solve this problem, and I'll put that 3 strategies in 3 different videos. So first strategy is it's not going to be very efficient, but that works. So it will run here, so I'll write the code and it will run here, but if you try to submit, it will complain about taking longer time. But we'll see that, because that's also very useful way to solve this problem, even though that's not efficient. But let's see this non-efficient way, how to solve these problems. And this is based on other videos. Like if you go to my channel here, search LeetCode, and then here you can search combination sum, and you'll find these 2 videos. So maybe you can go through the first, or maybe at 2, but watch this video. And this video comes under the 25 strategies. I explained 25 common strategies to solve LeetCode problems. So that is first 25 videos, and this also comes under first 25 videos. You see that, and based on this pattern I'm going to solve this problem. So based on that pattern I'm going to write. So in this pattern, what I do, I will take this one and take all, like, many ones, and I try to make it amount 11. Try and take the 2 multiple times, take 5 multiple times, and then from 1 I'll take the 1 2 combination, I'll take 1 5 combinations. So I'll try all the possibilities here, and I'll try all the possibilities and then find the array. First I'll find the array, like what is the array that contains a number and which make the amount 11. So I'll find all these array, and then later I'll find out which is the minimum, and then I'll just return that. So that's also one way, even though that's not efficient. But let's see that first. That's the first strategy I'm going to talk, and in the second strategy, in the next video, I will talk about solving this using the recursion with the dynamic programming, and the third video I will talk about solving this problem using DP array, and that's also dynamic programming. So we'll see that in a 3 different way. So let's see this solutions. So for this, let me create one helper function. So I'll just go ahead here and create the helper function, just copy this thing as it is. And for this function I'm just going to call this function, and before the calling here I need a result, so I'll create a variable result, and it's a type of two-dimensional array here, and this will this will collect all these arrays. So in this way it also will additionally will know what are the arrays, what is the number that is required to make 11. So we'll see all the possible the values here. So that's the result. So I'll pass coins, I'll pass amount, I'll pass result, and I also pass the index. So index I will start with 0, so let me pass the index, and here for result create this variable, and for index it's an int. And to store the temporary result that I explained in this video clearly, I'm going to create one variable called dp. This is a single dimensional array here. I'll pass that dp also, or I can just say ds, data structure. So I'll just pass the ds. Okay, so all these things I passed here, result, index, and then ds. So this kind of scenario where we need all the combination of 1, so in that case we do not want to increase the index, and then I need all the combination of 2 in that way. So for this, usually based on this strategy, usually the way I call this function twice. So I just call this, I'll call this amount, I'll call this result, int ds. So the way to write is call this twice, and here index plus 1, and for this we are not increasing the index because we just need the repeated value. When we call this function recursively, then we just need this value repeatedly. So that's why here I'm not increasing the index, and here I'm increasing the index. So that's the one change. And then also amount also we need to change. In this place we'll calculate the amount, and then we'll send the new amount. So new amount is amount minus it's a coin. So for this coins, let me make it a for array, so that's very easy here. Array a dot I, and in this call I'm not calling that. So that's thing, we need to have the conditions. The condition is if this ai is less than equal to amount, then only we call this function. Yeah, and I'm just writing this based on the previous video, the strategy, and I have explained over there very clearly. But basically if you just go through and come back, you'll understand this much clearly. So okay, so I call this before calling. I know the ai is less than amount, and that's the value is the possible value to reach to the amount. So that's why I'm going to add this in our ds. So ds dot append a dot ds and comma a dot I, and when this is done I will do backtracking here, and I will get rid of that value. So ds is equal to ds from 0 to length of ds minus 1. That's the backtracking is happening here. And then another one is I need the best condition or exit condition. So I I'm in index, I'm not increasing the index, but here in this call we are increasing the index. So the moment when comes, the index will equal to or it's like equal to the length of this array. So I can just check if index is length of array, then this time we need to return. And before return we need to also check because this amount minus AI, so we are sending new amount every time, so amount will get decreasing. So when amount is it's, and what is that? Okay, so the, and this amount is our target also. So in this case target, so target is decreasing, so I can say if target is equal to, or that's target is amount here, so if the amount is 0, when the amount is 0, then we found the combinations, and all this array is in the DS. So I'll create another variable ds2 make, and it's a array of int size of the length of DS, then copy all this value to ds2 from DS, and I will add that in this result, and this is the pointer, and here I need to pass address of this, and then at the result append result, and then ds2. So that's all, we got the answer in this result. Let's print this answer. So first of all, let me print empty println result, and then from here we'll go through each array. So I'm going to iterate this array, and that is result range result, and then return length of, we'll check, we'll need one mean function, so let me create one function mean a b int, and return int if a greater than b, return a, otherwise return b. So I'll call this function here. I'll create one variable, it's a mean, so it's a mean is equal to 0, and then we'll check here, I'll get this length, so I'll call the function mean. So main, I want to minimum length of this array, which combination makes 11, so that's a mean of mean, and comma v. So yeah, we'll see that. So mean v, and this mean v we just want to return. So that's all. Let's run it. Coin change, okay, we need to call this function first. I think we're calling that, which is the 77 unexpected return. We are not returning anything here. Line 5, passing too many arguments in call. Coin change, coins amount, result, index, and then DS. want int. So this is our coin change helper function. So I'll put that coin change helper, and here also. Run this time. Line 12, min is equal to minimum of mean and a and v. Cannot use v variable. Why? Oh, this is the array, so I have to say the length of v. Line 30 should be ind, that's index. Here also ind, so ind. One to 5, answer is 11. Expect output amount 11, standard output this, output 11, expected 3. So let's see, we have all the combinations here, 1 1 1 2, that's all the combinations, and this should be somewhere 5 5 10 11, that's also 5 5. So we have got this solution here, but then we are not okay, mean 0. So mean 0, I can make it like first max value, I can assign max, and that's why when you get the mean, then you can put your mean. So for this I'm using math max int, and it should run now. Again, expected 3 is our mean function. Oh, that's the problem. A less than b return. Okay, now what's else? So this time okay, so this time it's complaining about one value. Okay, so we need to check one more thing. If mean is equal to, that's math this one, still if the mean is this, then in that case return -1. Accepted, so that's good. But if I try to submit this, it will say the time limit exceeds, because here we have tried all these combinations. So but the good the benefit of this is at least we can see all these data here. So if the requirement change, you can make utilize of this data also. And this is the code, and I did not explain a lot like what is happening here, because I'm expecting you have already watched that video where I have explained all these very in a detail. So, and for now just I use a strategy and solve this problem. So in the next video we'll see more efficient way to solve this problem. So for now that's all. Thank you.